Welcome back. This is another video on the same topic, elements and the periodic table. So it is a continuation from the first part, so feel free, let us interact this lesson. Let us get started by looking at the objective that we're supposed to cover by the end of this video as well as lesson. So the success criteria that we're supposed to cover are as follows. By the end of this lesson, we should be able to cover the following. Should be able to describe the patterns in property of elements in the periodic table. Should be able to discuss the trends in the periodic table in terms of ionization energy as well as electron affinity. So let us start by looking at ionization energy. Remember, in our first presentation video on this topic, we said in terms of trends that we're supposed to look at, we're supposed to look at 4 trends that is there in the periodic table. We are supposed to look at atomic radius, which we have already covered in the first video. So in this video, we are going to cover more too. That is ionization energy as well as electron affinity. So what is ionization energy? We are going to start looking at ionization energy. So in ionization energy, we are going to start looking at the definition. So ionization energy can be defined as follows. It refers to the energy that must be absorbed in order to remove an outermost electron from an atom which is in gaseous state. It can also be defined as the minimum amount of energy that is required to remove an electron from each atom which is in gaseous state. So from these 2 definitions, the information is the same. In ionization energy, it means we are looking at the amount of energy that is required to remove an electron in an atom which is supposed to be in gaseous state. So the concept that we can always focus is that when ionization energy occurs, the atom is supposed to be in a gaseous state. So ionization energy process can be simply represented using an equation. So here we have an equation where we have M, which is in the gaseous state. Here we're going to have M positive, and here we have electron. So if we were to interpret this equation, let us look at the product side. We have a charged atom. Remember, we're saying M represents an element or an atom. So we have a charged atom here, or charged element here, and an electron. So it means in this neutral atom of this element, we have removed an atom. That's why here it is positively charged, which shows that now we have many protons than electrons. So let us go into details. If you check in the periodic table, some atoms have 1 electron in the outermost shell, others 2, up to group 7 where they have 7 electrons in the outermost shell. So if it has 2 electrons, it means we can remove all of them. Ionization energy is possible. But one thing that we need to keep in mind is that if we remove 1 electron from an atom which is in gaseous state, that process is known as first ionization energy. If we remove the second one, it's known as second ionization energy. We can keep on doing that until all the valence electrons are removed. So for this lesson, we'll only focus on 2. So the first ionization energy. So what is the first ionization energy? Okay. First ionization energy simply refers to energy that is required to remove the first electron from an atom which is in gaseous state. Second ionization energy refers to energy that is required to remove the second electron from an atom which is in gaseous state. So we can also define up to third, up to fourth, using the same concept on how we have defined these first 2. So first ionization energy is smaller in terms of kilojoules per mole to compare with the second ionization energy. This is due to increased nuclear charge after the first ionization energy. Let us go into details here. Remember, we are saying it's minimum amount of energy that is required to remove an electron from gaseous state. It means for you to remove an electron, you need energy. So we are emphasizing on the difference between the first and second ionization energy, where we're saying that in the first ionization energy, the amount of energy that is required to remove the first electron is smaller to compare with the amount of energy that is used to remove the second one. What do you think could be the reasons in change or in the difference between the energy used to remove the first and the second electron? So if we are to answer this, we will still recall back on shielding as well as the size of an atom and nuclear charge as well. All those three will help us through to understand why there is a difference in terms of energy needed to remove an electron in the first ionization energy and the second one. So if we remove the first electron, what happened to an atom? It means now the nuclear charge becomes more strong than the previous one. Why? After an electron have been removed, the strength that was offered to that electron now is distributed to the remaining electrons in the outermost shell, hence they are pulled inward. That's why the second one, to remove another electron, it means now the remaining ones are strongly attracted by the nucleus. So it is difficult to remove an electron during second ionization energy. That's why here we are saying that due to increase in nuclear charge, after you have removed one electron in the first ionization energy, the nuclear charge increase and the remaining electrons are strongly now attracted. Hence, the remaining electrons are strongly attracted by the nuclear charge. That's why the second ionization energy is more higher than the first ionization energy. More energy is required to remove one electron during the second ionization energy, due to the reasons that we have explained here. Examples of ionization energy of beryllium. Beryllium is from group number 2. It's an example of alkaline earth metals. So it has 4 electrons. We have 2 electrons in the first shell and 2 electrons in the second shell, which is the last shell. It has 2 electrons in the second shell, but the second shell is supposed to be occupying 8 electrons. So if we are to remove the first electron, we can check the amount of energy that is required. That is 900 kilojoules per mole. The second one, we have 1,758 kilojoules per mole. The third one, we have 1,490, and the other one we have 2,106. So if we check on the values, what is happening? As we are going inside removing the electrons, the values are increasing. Why are the values increasing? As we have removed the first one, it means the nuclear charge get much stronger and the remaining electrons are strongly attracted, which will require more energy to remove the electrons. So after removing an electron from a neutral atom, nuclear charge increases because number of protons inside the nucleus increase. Therefore, the remaining electrons are strongly attracted, hence the second, third, fourth ionization energy increases. So what happens to ionization energy moving down the groups of the periodic table? As we are going down the groups of the periodic table, we need to know the following. The number of electrons as well as protons increases. This makes the atoms going down the group to have more energy levels and an increased atomic radius. So we'll still buy the same knowledge on how we explained about atomic radius. So moving down the groups of the periodic table, ionization energy decreases. Why ionization energy decreases as we are moving down the groups? One, we have many electrons as we are going down the groups. It means they are going to occupy many energy level. The atomic radius increases as well. It means the outermost electron is weakly attracted by the nucleus. Hence, it can be easily removed. That's why the ionization energy decreases. Moving from bottom to top now. We are starting from bottom to top. The number of energy level now they are decreasing. The atomic radius is decreasing. The number of electrons in inner energy levels they are decreasing. Therefore, it means the outermost electron are strongly attracted by the nucleus and ionization energy increases as we are moving from bottom to top. But from top to bottom, ionization energy decreases because of increase in atomic radius, number of energy levels, hence the outermost electron is weakly attracted and can be easily removed. So here we have a diagram which is illustrating what we have shared in the previous slide. So we are saying that, for example, if we are to use group 1 element, we have lithium, sodium, and potassium. These are the first ionization energy values. If we check, for us to remove an electron from lithium, we need 520 kilojoules per mole. If we are to remove an electron from sodium, we need 496 kilojoules per mole. If we are to remove an electron from potassium, we need 419 kilojoules per mole. So if you check on the values, first ionization values, they are decreasing. The reason is that as we are moving from lithium to potassium, the number of energy levels is increasing. Shielding effect is also increasing. Therefore, the outermost electron here in potassium is weakly attracted by the nucleus. Hence, we expect that it is easier to remove an electron from potassium than in lithium. That's why here you see the value is decreasing. So moving from top to bottom, ionization energy decreases, but moving from bottom to top, ionization increases. Why? Here you have few energy levels and shielding is very minimal. Therefore, the outermost electron is strongly attracted by the nucleus and needs more energy to be removed. So what happened to ionization energy moving across the period? Moving from left to right, that means across the period, the number of energy level remain constant and the number of protons increases. Since we are adding number of protons, and maybe we have a question, we are adding number of protons, what happened to the number of electrons as we are moving across? Indeed, the number of electrons are going to be increasing, but where are the electrons going to be added? To the same energy level. Remember, you have constant number of energy level. If, for example, we are to go to group period number 2, it means all elements starting from lithium up to neon, they all have similar number of energy level. What differentiates them is the number of electrons in their outermost energy levels. Therefore, it means the nuclear charge for neon will be much stronger because there is less shielding. All of them, they are shielded by 2 electrons in inner energy levels. So it means it will be much stronger to attract the electrons. So moving from left to right, ionization energy increases due to increase in nuclear charge. Note, moving across the period, electrons are added to the same energy level. Hence, they do not shield one another, despite that there will be some sort of repulsion, but due to strength now of nuclear charge, they will be still attracted inwards. Therefore, more energy is required to remove an electron from such atom. This makes the electrons to experience the same force of attraction. This increased ionization energy because of the strong attraction which is offered by the nucleus to the outermost energy level as we are moving from left to right or across the period. So let us look at ionization energy across the period. So when we are talking about across the period, we are referring from left here to right. As we are to take this period number 2, we have lithium, beryllium, we have boron, we have carbon, nitrogen, oxygen, fluorine, and neon. These have the same number of energy levels, which is 2. The difference amongst them is now number of electrons in their outermost energy level. But in terms of nuclear charge now, since the number of electrons are increasing here, it means protons are also increasing. It means the nuclear charge starting from left to right is also increasing. As the nuclear charge is increasing, we expect the outermost electron to be strongly attracted since the energy level are constant. And we expect that in neon, the electrons are much less strongly attracted by the nucleus, followed by fluorine. Therefore, between these ones, we need more energy to remove an electron in such atom. Hence, we can conclude that moving from left to right or across the period, ionization energy increases. So we can have also the summary of period number 2. We have lithium, as we were saying. You can check on the values now. If you check on the values are increasing. So it means it is difficult to remove an electron from neon to compare with lithium. So summary of ionization trend of ionization energy in the periodic table. Moving from top to bottom, it decreases. While moving from bottom to top, it increases. While moving from left to right or across the period, ionization energy increases. While moving from right to left, ionization energy decreases. That is how ionization energy works in the periodic table. So from there, the third one is electron affinity, which is abbreviated EA. E means electron, A means affinity. So what is electron affinity? We can define electron affinity as ability of an atom to accept an electron. Ability of an atom to accept an electron, or it is a change, it's energy change that occurs when an electron is added to an atom in gaseous state. These are the definition of electron affinity. Now we can differentiate electron affinity and ionization energy. In ionization energy, we said an electron is removed, while in electron affinity, ionization electron is added to an atom. So atomic radius, nuclear charge, and shielding effect or screening effect, they are the factors which will affect the value of electron affinity, or are there factors which affect the electron affinity of atoms in the periodic table. We'll look into details about how do radius, nuclear charge, and shielding affect electron affinity amongst the elements in the periodic table. So if we can summarize the definition of an electron affinity in terms of an equation, we have an atom here. Let us check on the size. So in the size, we have this one is a little bit small. After we have added an electron, we find that this one has expanded and this one is a little bit big. So this one symbolizes or illustrate what happens in electron affinity. An electron is added to an atom to form an ion. So trends of electron affinity in the periodic table. What happens to electron affinity moving down the groups of the periodic table? Moving down the groups, we still use the same concept. Atomic radius increases, shielding effect also increases. This reduces the force of attraction. Therefore, the incoming electron is going not to be strongly attracted by the nucleus. Hence, moving from top to bottom, the electron affinity decreases. Repeat, moving down the group, we expect the following to happen. Atomic radius increases. Why does an atomic radius increase? Because of the increase in number of electrons. Therefore, number of energy levels are also going to increase. So if electrons are more, we expect shielding, where the inner electrons block the attraction to the outermost level electrons. Hence, if that atom is to attract the incoming electron, the electron will not be strongly attracted. Therefore, moving from top to bottom, electron affinity decreases. So let us consider group 7 elements. We should check on electron affinity values. We might find that in group 7 we have fluorine, chlorine, bromine, and iodine. So electron affinity values, fluorine has 349 kilojoules per mole, chlorine has 325 kilojoules per mole, and bromine has 319 kilojoules per mole, while iodine has 295 kilojoules per mole. So if you can check on the values are decreasing, which stipulate the same thing that we were explaining. As we expect that the atomic radius is increasing, the shielding is increasing, we expect that the elements at the bottom of the group will have higher shielding and will have weak nuclear charge to attract the incoming electron. So what happens to electron affinity moving across the periods of the periodic table? Moving across the periods, atomic radius decreases due to an increase in nuclear charge. Moving across the period, the atomic radius, let us understand this one properly. The atomic radius decreases. Why is the atomic radius decreasing? It is due to increase in nuclear charge. Remember, I said as the nuclear charge is increasing, the outermost electron is strongly attracted to the nucleus. Hence, the energy levels are pulled inwards, reducing the atomic radius. As well as shielding is not present, the increase in nuclear charge now will make the incoming electron to be strongly attracted. Therefore, moving across from left to right, electron affinity is increasing. I'll repeat on that one. We're saying that as we are moving across the period, the following phenomena or activities is happening. An atomic radius decreases. Why is an atomic radius decreases? Because of an increase in nuclear charge. So if a nuclear charge is increasing, it means the valence electrons are strongly attracted to the nucleus or nuclear charge. This makes the energy levels to be pulled inward, reducing the atomic radius. Therefore, the incoming electron is strongly attracted by the nucleus. Hence, electron affinity increases moving from left to right of the periodic table. This one can also be illustrated by the diagram. Let us check on the diagram. We have electron affinity. As we are moving across here, electron affinity is increasing due to decrease in atomic radius as well as increase on the nuclear charge. Going down, electron affinity is decreasing due to increase of atomic radius as well as decrease in nuclear charge. Moving from bottom to top, electron affinity is increasing due to decrease in atomic radius as well as increase in nuclear charge. Now we have a buzz session. A buzz session simply means a quick exercise that we are supposed to go through based on what we have covered in this lesson. So the first question is explain one major difference between electron affinity and electron and ionization energy. Explain one major difference between electron affinity and ionization energy. Define the following term: ionization energy and electron affinity. Define the following terms: ionization energy and electron affinity. Question number 3. Explain why elements with high ionization energies have higher electron affinity. Explain why elements with higher ionization energies have higher electron affinity. Explain why the third ionization energy of magnesium is much higher than the second ionization energy of magnesium. Which group has the following: the lowest ionization energy, the high electron affinities? Question number 6. Given the following elements, we have sodium, sulfur, nitrogen, chlorine, calcium, and aluminium. Arrange them in increasing electron affinity. So these are the questions that we need to attempt based on what we have covered in this video. So this marks the end of the presentation. If there is any question, you can find us on WhatsApp, and you can also visit xulendo.org to find more. For the resources, you can find more information about the concept that we have been disseminating in this video by checking on Excel and Succeed Junior Chemistry Book 2, Achievers in Chemistry Book 2, Target in Chemistry Book 2, and the illustrations, design, and graphics will be done by Dave Munga. For photos that we have been using, you can find the links here. You can click the link and find more, and maybe you can add other photos based on the links that are there. Thank you for the lesson.